Good morning, students. Still continuation, we are to do for the part of this topic, effect of temperature on resistivity and resistance. What I will discuss now is related to only for the problems. This formula is only for numericals. For problems. This formula already we have discussed. Resistance at T degree centigrade equal resistance at 0 degree centigrade into 1 plus alpha into T2 minus T1 means T minus 0 is T only. Alpha is the temperature coefficient of resistivity, also called as the resistance, one and the same. And platinum resistance thermometer. Platinum resistance thermometer is a device. Thermometer is a device which measures the temperature. Platinum resistance thermometer is used to measure the temperature. So based on the principle, what principle they use is the temperature of as the temperature increases, the resistance of the conductor means platinum increases. They increase the temperature. So temperature increases, resistance increases. By measuring the resistance, we can measure the temperature. The principle is used in the platinum resistance thermometer. So they don't need bother with the principle. So only thing is problem important here. If equal for alpha from this, alpha is nothing but equal to RT minus R naught. You expect in this bracket you will get R naught. This is nothing but equal to R naught plus R naught alpha T. R naught taken to the left side, you will get RT minus R naught equal to R naught into alpha T. And equating for alpha, what you get is RT minus R naught by R naught T you get. Next, same alpha is constant whatever the temperature you take. Second case, take the temperature 100 degrees centigrade. R naught is the resistance at 0 degrees centigrade. Then what you get here is R100 minus R naught by temperature what you take here is 100 degrees centigrade. T is 100 degrees centigrade. Then in that case, the alpha is equated, alpha is same, therefore equated. R naught cancels. Then you can measure the temperature by knowing only the resistances. Resistance at no temperature, at unknown temperature is RT. Resistance at the known temperature 0 degree centigrade is R naught. Resistance 100 degree centigrade is R100. Okay, means we are measuring the resistance of this with the method of the instrument. The instrument used to measure the resistance is called the ohm meter. Ohm meter is the instrument used to measure the resistance. And resistance is measured at 0 degree centigrade of the wire and at 100 degree centigrade of the wire and at given temperature T degree centigrade. We don't know what is the temperature, we have to find out that. Then by knowing the resistance values only we have to find the temperature. This will be asked for the numericals. This problem is there in the textbook, solve problem also. You just go through it. In this R naught, this R naught is resistance at 0 centigrade, R100 resistance at 100 degree centigrade. Instead, you may be given sometimes only for complex example. This is for not for speed theory. RT R1 is equals to R naught into 1 plus alpha T. R2 is equals to R naught into 1 plus alpha T. From this, you have to take the ratio of these two, and R naught cancels here. R1 is resistance at T1 degree centigrade. R2 is resistance at T2 degree centigrade. They don't ask the problem, they ask only the expression. So taking the ratio of these two, what you get is this is one equation 2. Taking 1 by 2, R naught cancels. You will get R1 by R2 is equals to 1 plus alpha T1 by 1 plus alpha T2. Cross multiply this. You will get R1 plus R1 alpha T2, R2 plus R2 alpha T1. Cross multiplication R1 plus R1 alpha T2 is equals to R2 plus R2 alpha T1. R2 minus R1 if I take, not compulsory, we take R1 minus R2 also. R2 minus R1 is equals to R1 alpha T2 minus R2 alpha T1. From this you can take alpha common out and get the expression alpha. Alpha is nothing but equal to R2 minus R1 by R1 T2 minus R2 T1. Only expression they will ask you for the competitive exams, symbols like this one. Alpha can be like this, it will be expressed. And what is the cause of change of resistance? That point is important for P theory also. important for 1 mark question for period. Cause or reason you can say of change of resistivity, or you can take even they may ask in terms of resistance, or they may ask even in terms of conductance or conductivity of material with the temperature. Material means we are talking here first conductors with the temperature. The reason is collisions of the electron with the vibrating atoms. Resistance appears because of the collision of the electrons with the vibrating atoms. We already discussed about the microscopic formula of the conductivity and resistivity. From that we get the other relations. Resistance, resistance of the electrons. Resistance is due to collision of electrons with vibrating atoms in current carrying conductor. Whenever the electrons are colliding with the vibrating atoms, they cannot move freely. So in that case, the free motion is not there, opposition is there, that is called the resistance. And we have already discussed the microscopic formula for the resistivity. If N is free electron density, resistivity rho is equals to N E square tau by M. N E square tau. Where M is mass of electron, N is or E is charge of electron, N is free electron density of material, and tau is relaxation time. Relaxation time. What is this relaxation time? Is time interval between successive collisions of electron with the vibrating atoms. N is constant. This N is greater than N, this is a constant N. For the given conductivity is constant. The nature of the conductor. M and P we cannot change mass and charge of the electron. So what we possible to change the change of temperature is collision with the vibrating atoms. Whenever the temperature increases, the vibration kinetic energy of the atoms increases. Collision probability with the electrons increases. Means what? Frequently they collide. Frequently collision means one time interval with the collisions decreases. Tau decreases. Whenever the tau decreases, resistivity increases. When resistivity increases, conductivity decreases. When rho increases, automatically R also increases. So conductivity is sigma. Conductivity sigma is equals to reverse of this resistivity 1 by rho is nothing but equal to N E square tau by M, and resistance R is equals to rho into L by A. L is length of the conductor, A is area of cross section of conductor. So what happens when the temperature increases? If the temperature is increased, then vibration kinetic energy of the atoms when temperature is increased, then vibrational kinetic energy of atoms increase. So what happens? Whenever the vibrational kinetic energy increases, the collision probability of electrons increases, and collision probability of electrons with atoms, means vibrating atoms, increase. So what happens then? The time interval with the collisions increases. Therefore, relaxation time tau decrease. So what happens now? Tau decreases means resistivity, and resistivity go increase because it is not increase. Whenever the resistivity increases, conductivity decreases. Increase, and resistivity increase means resistance also increases. Resistivity rho increase, resistance R increase, R increase, and conductivity sigma decrease. Conductance, I didn't give you. Reciprocal resistance is conductance. If they ask you for conductance, resistance increase means conductance decreases. Decrease. This is a case of temperature decreasing. Conductance G equal to 1 by R. Decrease. This point is important for field theory. I am giving you for increase of temperature, they will ask for decrease of temperature also. Reverse of the cases. Same point I will write once again here. For conductors which are ohmic substances, resistivity, or you can take resistance, increase with the increase of temperature, and decrease with the decrease of temperature. Increase with the increase of temperature, and decrease with the decrease of temperature. So if temperature decreases, the resistance decreases. Very close to the actual zero, if you have taken, the resistance can become equal to 0 also, but not for weak metals. It's observed according to that, except mercury. Only mercury was first observed. That resistance becomes 0 when the temperature is very close to absolute zero. We cannot reach to the absolute zero, minus 250 degrees Celsius approximately 0 kelvins. Practically we cannot reach it. Theoretically also, graphically only we can mention it, but actually we cannot reach the lowest possible temperature. So, but very close to the 0 degree centigrade, 0 Kelvin if you are going down. After liquefaction of the gases, all the gases, generally we go for the liquefaction of nitrogen, 72 kelvins approximately. Then in that cases now the mercury becomes superconductors, called as the resistance becomes equal to 0. Okay, and alloys, not two conductors, alloys, some alloys, we observe that they can become superconductors having the resistance equal to 0. That low temperatures properties are called as cryogenics. This is for the conductors. But if you take for semiconductors, reverse this. Semiconductor, example non-ohmic, silicon, germanium, they will become, which are non-ohmic also. If temperature increase, then resistivity rho comma r decrease. If temperature decrease, then rho comma r. What about the connectivity? Sigma, connectivity increases. Reverse property. Rho comma r increase. Sigma means conductivity decrease. Conductors, semiconductors means insulators also similar properties. We will find that opposite of the conductors. Next is superconductors. One more question for this. Superconductor. From this topic related one more question. Superconductor again comes in other topics also later in magnetism. That time case is different. Superconductors. Conductor with the resistance R equal to 0 is automatic resistivity rho is also equal to 0. Is called as superconductor. For superconductor, R is 0, rho is also 0. What about the conductivity? Sigma is 1 by rho, means it is infinity. And conductivity is 1 by rho, is infinity. Conductance, G is 1 by r, that is also infinity. Resistance is 0. There is no collision of the electrons with the vibrating atoms. It absolutely close to absolute very low temperatures. At very low temperatures. Close to absolute 0. Means 0 kelvins. Few alloys, some alloys get electric resistance. Equal to 0 and are called as superconductors. Special superconductors, they repel the magnetism. They are called diamagnetic. Superconductors repel magnetic poles or magnetic magnetic field begins. Magnetic fields. About this point again we will discuss later topics. This point is required later, magnetism related, but here in this topic what is required is resistance 0. Superconductor resistance is 0. Okay. Only alloys becomes, but purely except mercury, others pure metals, materials do not become superconductors. Next is graphs. 1 mark question or 2 mark questions. Graphs are very important. Resistivity temperature graph. Even in the recent NEET exam also they asked about graph. Resistivity versus temperature. T in K kelvins graph. Resistivity versus temperature graph. Only 3 graphs are there for you. One is for copper. Copper metal. Y-axis resistivity. Kelvin scale start from 0, no negative values for the Kelvin scale. Graph is not straight line, it's slightly curved. But for micro, in the NEET exam they asked for the copper. For micro, it is an alloy of nickel, chromium and iron. The graph is a straight line. Is the resistivity, is the temperature in Kelvins. The thing is semiconductors. For semiconductors like silicon, germanium, this graph generally repeatedly asked for PET, very important graph. Repeatedly asked for PET. This is a resistivity and temperature in Kelvins. This rectangular graph is a rectangular. Nature of the graph they don't ask, they only ask the diagram. It's not like exactly, it's not like the y-axis. The equation is not same as that of the RT equal to R naught, no, that formula is not applicable here. For a separate formula is there for semiconductors, it's not there for service. Only for competition we discuss later. It's important. Next is resistor. Resistance is a property. Like capacitance is a property. Capacitor is a device. Resistance is a property in which electrons collide with the atoms and cannot move freely. The opposition is nothing but the free motion of electrons itself is resistance. And a resistor is a device that provides the resistance for the flow of the electrons. So it is nothing but it's a device. It's an electric device. Electric device that provide resistance, electric resistance, or resistance for the motion of electrons. Resistor is a device that provides a resistance for the motion of electrons. Okay, and it's nothing but the same thing. Resistance is more means what? More collision of electrons take place. Resistance less means what? Less number of electron collisions will take place. Already we know the relation is R equal to rho into L by A. So resistance R is equals to rho into L by A we know. So if you want any material, every conductor has a resistance. And insulator has a very high resistivity. I give you the values. 10 to the power of resistivity determines resistance actually here properties. Length and area also further extra depends on the dependence for the resistance. If rho is more, R is also more. So R is high for the insulators. 10 to the power of positive values, 16 and 10 like that are there means they are the insulators. 10 to the power of minus 8 values are given means they are supposed to be conductors. Rho is very less for the conductors, very high for the insulators. So this R for the given conductor, we are talking about the resistance, not insulators. For conductors, resistance means R can be changed by changing the length and area and also rho. If rho is high, you don't have to take more length. With less length and area, proper area of cross section also, we can have the high resistance. So resistance is controlled. If you want the if you have the choice of the different materials, then we go for the high rho values. Okay, there is a case where we go for the low rho and high rho values. But resistance if you are using means for the small length only we need. Length only we need means resistance rho should be high values. So here symbol of the resistance important. But every material, every conductor and every material also can say provide has some resistance, which has a less resistance means already we have discussed that lowest rho value has the lowest resistance. What is that? Silver. Silver is having the minimum resistance for the given length and area compared to, and the next comes is copper, next comes is aluminum and so on. Okay. Resistance symbol, circuit symbol of the resistance, this symbol. Of resistance. Circuit symbol of resistance is this. Sharp edges here. No need to count how many, like triangles are sharp edges. And R is equal. If you take the variable resistor, circuit symbol means this one you have tried to use, one more question. Variable resistor means value can be changed. We just put an arrow. Put arrow across. Rheostat is also variable resistor. RH is a symbol. This is also variable resistance. Sharp edges means, and we can take on the top. This is A, B, X. This is the contact can be moved to and fro. This is the rheostat. The rheostat has three terminals, 1, 2, 3. This is a wire resistance connected and can be moved. This wire is a manganese or nichromesines. Manganese, nichrome, constant and preferred of the low alpha values, low temperature coefficient. So this terminals 1, 2, 3. This top one is the tapping point. This one. We can move it to and fro. When you are moving this and this side, the resistance value changes. As L changes, the resistance also changes. This is the length of the wire. Actually. Wire is wound like this. This wire contact point changes. So in that case, as the contact point changes, the resistance also changes because L changing. Area cross section of the wire constant. As length increases, resistance also increases. What is the use of resistance? Resistance used to use the control the resistance used to control the current in the electrical circuits, like increasing the volume of the sound in the speakers, radios, TVs. If you want to increase the volume, then resistance need to be increased. By rotating the knob, you decrease the resistance. When resistance decreases, current increases, the sound also increases. So resistance is used to control the current in electrical circuits. Resistor is used to control the current in electric or electronic